Let's get straight into it. Huge round of applause for Daniel Finneran, please.
Cool. Thank you very much for having me today. Today I'm going to be talking about Kubernetes. I'm going to be talking about a new project which is a little bit in its infancy. It's a project called Gateway API, and how we can look at using the two to manage kind of on-prem and edge networks. So this is kind of a quick agenda of what I'm going to be going through, kind of why I decided to kind of submit this talk when I realized that kind of NetDevOps Days was going to become a thing. We're going to talk about Kubernetes. In brief, a little bit kind of what it looks like, how the architecture of it kind of hangs together, and its networking magic. I'm hoping I'll have kind of got my head around being able to do this. At the last KubeCon in North America, my hotel room was cancelled, and I ended up booking a last-minute hotel on the Hilton app, not realizing that the hotel wasn't in Detroit, it was in Canada. Every day I had to go through the passport control and speak to a very angry border control person about why I was going to KubeCon and explaining to him what Kubernetes was every day for a week. So hopefully I've kind of got it there and I can kind of deliver that. We're going to be covering Gateway API. As I mentioned, this is a bit of a new project, the future of Kubernetes networking. We're going to talk about how Kubernetes can interact with physical networks. If I do get a DHCP lease, I'll do a demo. If not, I've recorded it, so I've got the chicken's way out to a certain degree. A bit of a wrap-up, and then if we do have time for some Q&A. So before we kind of begin, I hope your shoulders are prepared. Who's heard of Kubernetes? Oh, that's okay, that's cool. I wasn't entirely sure what kind of response I was going to get there. So second question then, who's actually using Kubernetes? Okay, cool. All right, fantastic. So for those who are kind of coming to Kubernetes kind of new, it's kind of becoming a bit of the default for new and modernized applications. So people deploying to the cloud and kind of running newer applications that they're building. But out of the box, Kubernetes doesn't actually do any networking. Out of the box, Kubernetes doesn't actually do anything really. It's basically needs a lot of other components bolted together for it actually to be a fully fledged platform. It comes out of cloud infrastructure, so it comes out of Google, originally Project Borg. And because it comes out of cloud infrastructure, it normally expects a lot of that infrastructure, that plumbing to already exist. Until recently, a lot of the plugins that provided the networking side of things were largely just focused on giving out those internal IP addresses, which I'll talk about in a little bit more detail. And connecting it to and interacting with physical network infrastructure is a completely separate and new task that we're now kind of having to deal with. So this is starting to become a bit of a problem now. We're moving past people kind of playing with Kubernetes. It's finding itself in a lot more places. Telcos, especially at the moment, we're seeing a lot of people kind of moving things like the 5G cores onto Kubernetes. People are packaging up a lot of those kind of special CNFs. We've gone from VNFs, which are virtual network functions, to CNF, which are containerized network functions. So we're seeing a lot of the telcos wanting to re-platform onto Kubernetes. That comes with its own set of requirements to interact with, kind of the quite crazy networking that exists inside telcos. Newer applications that are being developed have to bridge. So people are moving their existing applications onto a Kubernetes platform, but it still needs to speak to existing infrastructure. So we need a way of being able to bridge between the two. So Kubernetes and its networking magic. We're kind of quickly going to go under the covers in terms of what Kubernetes actually looks like from a networking architecture standpoint. So to begin with, this is my server, Dan's server. It has an IP address on a network. I install my program on there. I connect to that IP address. I connect to the application running on that server. That's simple. That's the way it's been forever. A few years ago, the concept of Dockerizing applications came along. That effectively made it much easier for people to take their application, effectively put it in a box, and then run that box as expected anywhere. So that's kind of what things look like now. You get a Docker container. I put my application in that Docker container. It has an internal IP address, so I can't access my application directly. I would need to tell Docker to expose that application on a port to my machine, at which point then I can connect to it as expected. So this is kind of what Docker networking tends to look like. Each Docker image runs as a container. That container lives on its own internal network. I need to expressly expose that container in order to actually access the program that's running in it. So that's running an application inside a container. This is what a Kubernetes cluster actually looks like. So take that single application, that single pod, that single container, scale it out massively. Some of the Kubernetes clusters we start to see today are in the realm of 10,000 nodes, all running, each node running a multitude of containers and things like that. So it starts to get very crazy very quickly. A bit of a naming change here. So you can see we say pod. In the concept of Kubernetes, you can run multiple containers inside a pod, should you want to. You don't often tend to see it, so for most purposes, just think of a pod as a single container, because we're moving away from that model anyway, typically. So each node has an address on the network, but each pod has its own internal IP address. So as you can start to see, we need these massive internal underlay networks, and then we need to work out how we're going to actually expose all of these pods to the outside world as an application. So this is where things start to get a little bit kind of crazy. So I'll take one of my nodes here. This is worker 1. I have the external IP address on the network where this machine actually lives. I'm running my application inside a pod. It's been given that internal IP address. My application is made of multiple pods. So in order to expose my application, what I need to do is I need to create a service. This is another Kubernetes concept. A service effectively is how I take my application and expose it to the outside world. So yet another internal IP address here. So I have my 2 pods. These are my applications that are actually running. I've now created a service which will effectively load balance between all of the pods that it cares about. So this service has been given that 10.96 address. If I were to go to that IP address, I would go to one of the pods that sits underneath it. Does that all make sense? Okay, cool. So this service address is internal. I can load balance internally across my pods. Great, but the outside world needs to get access to my applications. What does that actually look like? So pretty much the simplest and easiest way of exposing and getting traffic into a Kubernetes cluster is the concept of a node port. So a node port effectively will attach this port to the external IP addresses of the node itself. And then regardless of whichever node that I actually hit in the cluster on that port 30,000, traffic will be forwarded to my service, and my service will then send traffic to one of the pods that sits underneath it. So that's basically how traffic gets into a Kubernetes cluster in its most simplest form, using the concept of a node port. To make things a little bit more crazy, there's also a lot more different ways of getting traffic into a Kubernetes cluster. A node port is pretty easy to use on very small clusters, but it doesn't scale very well. If you want to think about how a lot of people want to use Kubernetes clusters, they don't really want to continuously worry about worker 01. They want to blow nodes away. They want to add new ones in. We really don't want to have to keep working and focusing on these IP addresses that are going to come into life and die as we create and destroy nodes, upgrade, grow and scale and all of those sorts of things. So we need another way of actually being able to have IP addresses that exist outside of the Kubernetes cluster that will still get traffic into the cluster itself. So if we look at how most clusters kind of work in places like AWS and things like that, I have the same concept here. I have a node that's actually running. I have a pod on there that I want to expose to the outside world. Again, I create a service. But this service is a different type of service. It's a service type load balancer. So this service has been given an external IP address. And it's the job then of the external load balancer to receive traffic from that new IP address, send traffic to one or any of the nodes in the actual Kubernetes cluster, which has now been programmed that if it receives traffic from that load balancer IP address, send it to the service, send it to the pod underneath. So because now we have that external load balancer, we don't really need to care about which server is living underneath. The load balancer will take care of being able to know which machines actually exist in that pool. So that's kind of how most things kind of look from an ephemeral point of view, being able to add and remove machines from a service type load balancer perspective. So some quick observations. If we're wanting to do this on-prem and in edge and things like that, where does this external load balancer come into play? Do I need to have an F5 load balancer? Do I need to have some dedicated equipment? What are the other alternatives out there? Who's managing IP addresses for these external IP addresses? And what's updating the physical networks to any of these changes? A lot of this is kind of pretty much glossed over when we talk about kind of cloud infrastructure, but when we're wanting to implement it ourselves, these are all sorts of things that we actually need to concern ourselves with. These are things that we need to implement, or we need to find projects that will help you implement those features. So one other kind of bit that I kind of haven't mentioned yet is another concept of Kubernetes, which is the Cloud Controller Manager. And the Cloud Controller Manager, it's called a Cloud Controller Manager, but you can run it at home, on-prem, on the edge, whatever. But effectively, the Cloud Controller Manager's role is to be the bridge between a Kubernetes cluster and the infrastructure of where it's running. So for instance, in AWS, the Cloud Controller Manager speaks AWSese, and if you request a load balancer IP address, it will speak to the AWS APIs, get you that IP address, set up a load balancer, send all that information back into the Kubernetes cluster, and effectively join the dots between the cluster and the infrastructure. So that's effectively how you kind of marry the two together. So a bit quick Kubernetes networking recap. A pod has one or more containers, and it has that internal IP address. You don't tend to access them directly. A service will create a new IP address, which will then redirect traffic to one or more pods that sit underneath that service. To get traffic into that service from an external point of view, we need a node port or a load balancer. And then something needs to connect our cluster to the underlying infrastructure one way or another to ensure that the resources exist and to do the configuring of that cluster accordingly. So that's typically how people have been managing. That's a very, very quick overview in 10 minutes. There's been conferences that have effectively been 3 days that have explained all of that before. So that's a very quick overview of Kubernetes networking. We're going to talk about a new project which aims to simplify a lot of the networking for Kubernetes clusters. And this is effectively application networking, how an application looks and things like that, and how that is going to transfer down to the real world. So why Gateway API? Why do we need yet another layer on top of another layer on top of another layer for organizing things and defining things? Well, the current design blurs a lot of the lines of responsibility. Who creates the service type load balancer? Is it the applications people? Is it the infrastructure people? Is it the networking people? Is it the ops people? There's no clear delineation of who really should be kind of in charge of all of that. The basic design of Kubernetes is becoming kind of, the basic design is kind of limited. The more places that Kubernetes is finding itself, we need more ways of having more fine-grained control about how things are defined. And the high level of abstraction, so not just load balancer IP addresses, but also layer 7, ways of getting traffic in where we kind of inspect the actual application data to determine where things are going. There's been a lot of toil and a lot of different ways of expressing that, which means that moving from one configuration to another basically almost means learning a new language to a certain degree. So the idea is to kind of standardize. So, as I mentioned, what do we hope to achieve? Standardization. That clear separation of responsibilities, making it extensible, so allowing other technology vendors to easily create their own implementations of Gateway API, and kind of a hierarchical design that's kind of easy to understand. So, quick recap. I have 3 pods. I have a service that exposes those 3 pods. They're given that external IP address. Traffic hits that load balancer IP address and goes into the application. From a gateway API perspective, this kind of changes. So we have the gateway class. The gateway class is the vendor-specific implementation of Gateway API. So for the demo that we're going to hopefully do in a few minutes, we have a NetDevOps Day gateway class. So I've basically written an implementation just for today. Underneath the gateway class, we have the concept of gateways themselves. So the infrastructure people have created me 3 gateways for 3 different use cases. So I have a production, a testing, and a services gateway. And each of those gateways is given its own IP address. So At the moment, these gateways aren't connected to anything. These are just 3 gateway instances that have been created. IPAM's done some magic and given us some IP addresses for those gateways. To actually make use of those gateways, we have the concept of routes, and this is what the application people will be making use of. So routes are used to map from the service that we talked about earlier to the gateway, which is the external way of interacting with the concept of Gateway API. So the most common is the HTTP route. This is the layer 7 way, so ingress has been a bit of a nightmare inside Kubernetes. There's been lots of different ways of doing it. The idea originally with Gateway API was to quickly standardize on HTTP routes coming in there. The main routes that are being addressed now, TLS route, which is encrypted traffic that is coming into your Kubernetes cluster, and then TCP route, which is handling TCP ports coming in, UDP routes, same but different. And then additionally, there's work on gRPC routes, and additional routes are being looked at being added in the future. So what does that actually look like? So we've got my gateway class, we've got my 3 gateways defined for 3 different use cases. These are sorts of what the routes would actually look like. So from the production, I've added in a TCP route, port 443, which is going to be HTTPS traffic coming in. I have a HTTP route, so if somebody hits /login on 443, then it's going to be sent to a different backend service, which will be some web servers that handle the login process, for instance. The backend services has a UDP route for port 53, so we're doing DNS, etc., so on and so forth. So this is what the architecture actually looks like. And you can kind of see the delineation is kind of quite simple. The application people handle the bits that make sense to them, that exposes their application itself. The networking and the ops team actually handle the networking infrastructure side of things, so the IP addresses and where things actually live from that. And the infrastructure as a whole people, they take care of implementing the actual gateway class itself, so the overarching infrastructure as such. So quick recap, gateway class defines the implementation. The gateway is the network endpoint for the actual cluster itself. And then the routes are the different ways of interacting with that gateway itself. So the maturity at the moment, so I know we've got beta and alpha in here, which sounds a little bit scary, but if you actually look at most things in Kubernetes, they're usually beta or alpha anyway, and in production, and have been in production for like 5 or 6 years, which is a bit terrifying, but this is the world that we find ourselves in. So gateway class and gateway and HTTP route are now beta, which means they're largely ready for GA. Gateway API itself is at 0.7 and will be 1.0 release in time for KubeCon North America Chicago in a couple of months' time. And then alpha is TCP route, UDP route, TLS route, and gRPC route. So Cilium is kind of one of the forefront company projects, that is actually working on Gateway API at the moment. We have a number of maintainers of the project that are actually part of the Cilium project itself. The gateway class and the gateway are first-class citizens inside the Cilium project, as are HTTP routes, which map directly to the service mesh element of the Cilium project. The TCP routes and UDP routes are being worked on and are going to basically move people away from the simple concept of the service type load balancer as we move forward. And because it's an open source project, we'll probably add those additional routes, or members of the community will add those additional routes in as we start to see them start to pick up and get more traction. So, interacting with physical networks. There's a number of different ways I've shown that you can define how an application looks from a networking perspective inside Kubernetes. We actually now need to interact with the physical world in order for things to actually make sense. So, gateway class, we have a gateway. That gateway needs to get an IP address from somewhere. So we have the concept of controllers inside Kubernetes. This is yet more naming nomenclature for you to be aware of. But the controller is actually the code that's running. So we write a gateway controller. And that gateway controller's job is to watch for new gateways and actually do the magic. So I've requested a gateway. The gateway controller is going to actually do the gateway magic for us. If you were to write your own gateway controller, you could write your own IPAM. I wouldn't advise it, but it's up to you. If you're going to do it properly, there are a lot of open source projects out there, but the Cilium project will take care of doing the IPAM for you. So The Cilium gateway controller will be given various IPAM information about the network that it's in. It will get you an IP address, update that gateway controller, and it will update the gateway object actually with it. For today, I was actually hoping to get a NetBox setup working. Unfortunately, when I got the message from Mark that my talk had been accepted, I was actually just flying out on a family holiday to Greece, so I didn't have enough time to actually implement it, but I have a demo that if you squint enough, it will look like what I was hoping to happen. We have a gateway controller. The gateway controller does the IP address allocation for our gateways. We now want a TCP route, which is going to be the port side of things, getting traffic into that gateway. So same thing, we've defined a new TCP route. We have our TCP route controller. That's going to need to do the magic of creating a new service for us, creating the new load balancer types for us, and updating that TCP route so that we now have the fully fledged out configuration. So I still haven't really mentioned physical networks. How are we interacting with physical networks? So what does that actually look like? Well, there's a couple of common types of ways that we interact with physical networks. The simplest and for smallish networks is effectively ARP, so Address Resolution Protocol. So I have 3 nodes that are half off the screen, which is going to make the next bit annoying, that are connected to a switch, and then there's a machine that's going to be trying to access something. You can't see, but there's meant to be a little smiley next to the first node, which is just off there. What effectively that means is that one of the nodes in the cluster will need it to be effectively elected as a leader for this new service. Node 01 has been affected the leader, so it has the load balancer address attached to it. We now do an ARP broadcast so that the rest of the network now knows that to go to that load balancer IP address, I need to use the MAC address, so the hardware address of that machine itself. Should that machine die for whatever reason, we upgrade, we need to, well, the machine physically dies, whatever. That machine disappears off the network, a new leader election occurs. This machine's been voted the leader, it's been given the IP address, it updates the network, traffic now knows where to go in this environment in order to get to that load balancer IP address. Traffic then hits the service, goes to the pod, no one's none the wiser, everything just works. From a BGP perspective, a little bit different, but effectively what we tend to do is all nodes will have the load balancer IP address attached to them. All of them will advertise to the switch, the top of rack switch or the router or whatever. I have, please add me as a route in order to send traffic to this load balancer IP address. In the event that one of them dies, that route is no longer being advertised and traffic will just go to one of the other nodes that are advertising that route. And that's typically how most implementations work of advertising load balancer IP addresses through BGP. Demo time. Okay, so, no pressure. Okay, cool, it seems we're working. Let me just put my water down. Right, so I have a brand new, yes, right. So I have an empty Kubernetes cluster. We're interacting with the kubectl tool, and I've asked to look at the gateway class, the gateways, the TCP routes, the pods, and the services. The only service that exists at the moment is the internal service for Kubernetes. You don't really need to worry about it, but that is just how Kubernetes kind of speaks to itself. So what we're going to do first is we will deploy our application. And I'll watch me type really slowly. So I'm deploying Nginx, so if we, it's a little bit easier to see, right. So do the same thing, we can see here, I've got 2 Nginx pods that are actually running. They've been given some internal IP addresses, etc. I need to expose those to the outside world. So what we'll do is we will create a gateway class. So I've applied my gateway class. We can now see my NetDevOps Days controller is actually up and running. So we now have a NetDevOps Days Gateway API implementation. Next thing to do is to apply the gateway itself. And all things being well, let me clear this, sorry, bear with me. We should have, there we go. So we have our gateway. And we can see through the magic of IPAM, it's been given an external IP address. The final thing for us to do is to attach a TCP route, which is how we will get traffic into that gateway, into our Nginx pods. If I can type. So I've applied a TCP route. If we look at this now, yep, so we have, you can't see half of it. We have a TCP route that's 1 second old or whatever. But the main thing here is it's created this load balancer with the gateway IP address and this port being attached to it from the TCP route. And if that works, there we go, fantastic. So my TCP route is connected to my gateway. Underneath that, it will now connect to the pods that sit underneath it. So that is the full stack of all of the components actually needed to require to expose your application to the outside world using Gateway API. Cool, so my demo actually worked. I'll take that. And the networking kind of stood up, but room's full of networking engineers, so if it didn't work, I know who to ask. So, the wrap up. So, as Kubernetes continues to find adoption in new areas, which it is continuously finding new strange areas and things like that, edge, telco, IoT, etc., we're finding new areas where the original design of Kubernetes is kind of creaking under the requirements of that. We're getting these mega clusters where larger teams are having to share cluster infrastructure. Again, that original networking design no longer kind of fits the bill, so we're having to come up with new methods, Gateway API being one of those, how we can kind of shard the design, have that hierarchical overview in terms of how things kind of hang together. And finally, as Kubernetes lands itself in more and more exotic locations, we're having to find new ways to get Kubernetes to interact with that infrastructure in order to make what's actually running on there be exposed to the outside world. So there's a lot kind of going on in Kubernetes. If you are wanting to learn more, there's a lot of different ways that you can kind of get Kubernetes. You can run it locally on your laptop through projects like Kind. The Cilium project has a lot of labs where you can spin up various different bits of Cilium infrastructure and play with all of the Cilium networking under the covers and things like that. So with that, if anybody has any questions, if not, thank you very much.
We were sat at the back saying he's brave to do that demo live, but seems like it worked out. Okay, we do have time for a bunch of Q&A. Looks like we've already got our first one. Take it away.
Hello, I'm Ollie from Acronis. Does it support IPv6?
Gateway API?
Yes.
Yes.
Good answer.
So
That was an easy one.
yeah, so I mean, so Gateway API actually is kind of a funny thing. Gateway API is actually just a spec. The implementation is a vendor-specific thing. So I was, as me, the DevOps thing, I wrote my own implementation of it. So it really is down to who's implementing Gateway API. For instance, the Cilium project implements Gateway API. Nginx have their own implementation of it. And most of them out of the box support IPv6. Most of the Kubernetes project itself is now moving to be either dual stack or IPv4 or IPv6.
Wow.
Sort of following on from that, a big problem that we have at the moment is getting UDP IPv6 traffic specifically into cloud provider hosted Kubernetes clusters. What we do currently is use Cilium to pass traffic from local surface into the cloud, which is just a nightmare. Does Gateway API provide us a way to build a gateway class and a controller that can abstract much of the hassle of setting that up?
So it could do. As I mentioned, Gateway API is a spec for you to implement however you would want that. So you could implement a UDP route for that particular use case. We would need to write some potentially eBPF specific code in order to do the UDP specific things that you're actually asking for. But there is no reason why that couldn't actually be implemented as its own Gateway API implementation. They probably don't want to be mentioned, but there are people at the back of the room who can probably help you with a bit more information. They can raise their hands if they want. Yep, there they are. Cool.
Yeah, hello, my name is Don. So quick question, by look of the demo, is it the intention by the gateway API to replace ingress as such? Because you mentioned something about HTTP route. Would it have the same functionality to like place multiple backend and yada yada yada, add in TLS certificates?
Yeah. Yeah, I mean, the original kind of concept between Gateway API, and a lot of it is the maintainers of it were maintainers of projects like Contour and things like that, which are ingress controllers, was that each ingress controller had its own esoteric way of defining what ingress actually looked like. The idea really was to standardize that. So the HTTP route and the gateway are largely an attempt at standardizing how that actually looks. So the idea really is that you could take the same HTTP route, change the gateway class to a different one, and that HTTP route would just still work. So as I say, it's a standardization in terms of how you get traffic into a Kubernetes cluster.
Yeah, hi.
It looked like when you created the TCP route, that's what did the service registration. Is that what's happening under the hood?
Yes, so for TCP route and UDP route, dependent on the implementation itself, the one that I did basically creates a service type load balancer. Some of the other implementations that have more control in the data plane, for instance, they don't need to do a service creation. They will actually do the mangling of packets themselves. They'll actually take care of all that stuff for you. As I mentioned, the TCP route and the UDP route are both in alpha at the moment. So there's a lot of different implementation methods in order to define how a TCP route actually gets traffic to the backend pods itself.
Time for one more question.
Sorry, just one quick follow-on. So what does the service registration in DNS?
So, I mean, there's internal DNS through core DNS itself. There's also an external DNS provider as well, for instance. So, for instance, I've said that a lot. You create a service, you give that service a name, it'll have an internal DNS entry. You can also have external DNS which will push that to bind or whatever it is that you're using, Route 53, etc. That will map that IP address to the DNS name that you're actually wanting to specify it to. So hit that DNS name, it goes to the load balancer IP address, it goes to the pods, etc.
Yeah, sorry. Comparing Gateway API and Ingress,
Yes.
you're saying that there's a standardization for elements of it. How are you doing like advanced configuration, like header manipulation or anything along those lines? I also saw in your files that you're using labels to make it behave in a certain way. Like that seems a lot like Ingress, just with more words and letters than kind of any benefit to me. I'm
Yeah.
missing something.
Yeah, so I mean, the HTTP route at the moment, a lot of the average functionality is implemented into the basic spec. There are still going to be some implementations of the layer 7 magic that require more annotations being added to your HTTP route, which will be doing vendor-specific things. The idea really is to standardize as much of it as possible, because at the moment, you could still move a HTTP route from one vendor to the other, and the majority of it would actually work with HTTP route. With the current way of defining ingress at the moment, there is no way of moving from one to the other.
So there's a standard spec under networking, k8s v1 for Ingress that
Yeah.
does exactly that. So I'm a bit confused as to where you're saying there's no standardization. Because there is an Ingress controller spec that an Ingress controller has to conform to in order for it to be accepted and deployed to Kubernetes cluster.
Yeah, so I mean, the spec is not just the ingress spec, it's also the spec between service type load balancers, service, TLS sort of thing. There's a lot of different ways of getting traffic into a Kubernetes cluster, and they're all markedly different. Ingress has started to standardize, but the idea is that we standardize across all of the different networking methods of getting traffic into a Kubernetes cluster.
Stein, I forgot you. You still want to go?
Really quick.
Yeah.
This is the talk we want to go long on anyway. Just to bring it back to the networking plebes in the audience who thought this was all black magic, do you have any recommendations on, well, the old saying is using Kubernetes is one thing, but running and operating it is completely different. Do you have any tips for, if you're doing your own MSP, your own rollout, and you're starting on your journey, what type of tooling would you use to manage? Because the VMware guys that you might have will laugh at you when you say, hey, can you manage my pod cluster? Good luck. How do you recommend bridging that gap, when you start rolling out?
Yeah, I mean, so to kind of get initial learning, so there are a lot of different tools that you can easily run on your laptop. So there's like Docker Desktop, for instance, and you can toggle Kubernetes, and then you'll have a Kubernetes cluster that's running on your laptop. If you're running Linux, then you can install it locally and things like that. There's a lot of demo applications which can be used in order to kind of show you a little bit of what the internal infrastructure actually looks like. Some of the better tooling I find in order to kind of picture what's actually happening is some of the visualization tooling, which actually shows kind of how things are actually mapped together. Because you throw a bunch of YAML at a Kubernetes cluster and it either works or it doesn't. And if it doesn't work, trying to work out what has broken is kind of a bit difficult. So there's some tools like there's a tool called Hubble. You can install that. You can then look at your Kubernetes cluster through a GUI, and it will basically show you the mapping of your pods to a service, to this, that, and the other. And it'll draw all the little lines. If you've got your labels wrong and your service exists and your pod exists, but traffic isn't getting to them, you'll get the visualization which shows you where you've gone wrong. All of that sort of stuff. So yeah.
Great. Let's have another round of applause for Daniel Finneran, please.